Hello everyone. Today we are going to study equation of a plane in normal form. Till here we have learned to find the equation of line in space in Cartesian as well as vector form. Now we will study about plane. So the first topic is equation of plane in normal form. Let's say this is the plane and this is the point O, which is representing origin. If I draw perpendicular on this plane, and let this perpendicular meet the plane at the point N. So this ON will represent a normal vector to this plane. So ON is a normal vector to this plane. ON vector is normal vector to the plane. Suppose ON is equals to D units. The distance of ON is D and N cap is the unit vector along ON. N cap is the unit vector along ON vector. Therefore, we can write ON vector as magnitude into direction, where D is the magnitude and N cap is the direction. Now suppose R is any arbitrary point in this plane. R is any arbitrary point in this plane. Then if I join O and R, then this vector, let's say this vector is R vector. It will represent this position R. So position vector of this particular point R is R vector. This is ON vector and let's say this is NR vector. Now you can see that this NR vector lies in the plane and this ON vector is perpendicular to the plane. So we have that NR vector and ON vector are perpendicular, and we know that the scalar product of two perpendicular vectors is 0. Therefore, NR vector dot ON vector is going to be equals to 0. The scalar product of two perpendicular vectors is 0. By triangle law of addition, we have ON vector plus NR vector is equals to OR vector. This result we have from triangle law of vector addition. So from there you can put the value of NR vector. So NR vector will be equals to OR vector minus ON vector dot ON vector. It is equals to 0. Let's put the values. OR vector can be written as R vector. ON vector can be written as D into N cap dot ON vector can be written as D into N cap, and this should be equals to 0. Now we will multiply R vector by this thing. So it will become D times R vector dot N cap minus D square times N cap dot N cap. Now we know that N cap dot N cap is modulus of N cap, and modulus of N cap, because it is a unit vector, modulus of N cap will be equals to 1. So it will become D times R vector dot N cap minus D square times modulus of N cap, which is equals to 1. So this is D times R vector dot N cap minus D square into 1 equals to 0. So from here you can say R vector dot N cap is equals to D. So this is the equation of plane. In the normal form. R is the position vector of any arbitrary point. N cap is the unit vector along the normal to the plane, and D is the distance of the plane from the origin. D is the distance of the plane from the origin. So here I am mentioning that D is the distance of the plane from origin. Therefore, it is required that D must be positive. D must be positive. Now in the Cartesian form, let's try to write the equation of plane. In the Cartesian form, let's try to write the equation of plane. Suppose that the coordinates of the arbitrary point R are given as x1, y1, let's say the points are x, y, z. These are the coordinates of the point R. Therefore, the position vector R vector in the component form will be xi cap plus yj cap plus zk cap. Now let L, M, N be the direction cosines of the vector normal to the plane. Therefore, we can write n cap in the component form as L into I cap plus M into J cap plus N into K cap. From the vector equation we have, if we consider the vector equation of plane, we have R vector dot n cap is equals to D. Let's put the values of R vector and n cap. R vector is xi cap plus yj cap plus zk cap dot li cap plus mj cap plus nk cap is equals to D. So from here you will get Lx plus my plus nz is equals to D. So this is the Cartesian form of equation of plane. Lx plus my plus nz equals to D, where L, M and N are the direction cosines of the vector normal to the plane, and D is the distance of the plane from origin. Now let's do some questions. The question is, find direction cosines of unit vector perpendicular to the plane whose equation is given by R vector dot 6i cap minus 3j cap minus 2k cap plus 1 equals to 0. We need to find the direction cosines of the unit vector. Now if we compare it with the vector equation of plane, so the vector equation is R vector dot n cap equals to D. So let's convert this equation into the standard form. So it will be R vector dot 6i cap minus 3j cap minus 2k cap is equals to minus 1. But we know that this distance D is always positive. So for that purpose we will multiply minus 1 both the sides to make this distance positive. So what we are doing, we are multiplying both sides by minus 1. So what we will get R vector dot minus 6i cap plus 3j cap plus 2k cap is equals to 1. The signs get changed because we have multiplied it with minus sign. So this is the standard form of the vector of the plane in vector form. Now what we need the direction cosines. Direction cosines can be obtained from this part. This is the n cap. But here you can see that this is the normal vector. which is given to us, minus 6i cap plus 3j cap plus 2k cap. It is not the unit vector. So we need to find the unit vector. For that purpose, we will divide this vector by the modulus of that vector. So let's calculate the modulus of that vector. That would be equals to minus 6 square plus 3 square plus 2 square and its square root. So it will be 36 plus 9 plus 4 and its square root. So it is going to be square root of 49, that is 7. So now we will divide this vector by its magnitude 7 so that we can obtain the unit vector. So unit vector would be equals to minus 6 by 7 I cap plus 3 by 7 j cap plus 2 by 7 k cap. Now the coefficients of I, j, k over here represents the dr's, direction ratios. So the direction cosines. Direction cosines. Minus 6 by 7, 3 by 7, 2 by 7 are the required direction cosines. Let's take another question. Another question is, find the distance of plane 2x minus 3y plus 4z minus 6 equals to 0 from origin. This is the question. Find the distance of the plane given in the Cartesian form from the origin. Now let's write down the standard form. The standard form is Lx plus my plus nz is equals to d, where L, M, N are direction cosines and d is positive. So let's write down this equation. It is going to be 2x minus 3y plus 4z is equals to 6. Here d is positive, but these are not the direction cosines. These are the direction ratios. So to convert them into direction cosines, what we will do, we will calculate the modulus of the normal vector. So from here you can observe that the normal vector will be 2i cap minus 3j cap plus 4k cap. So its modulus will be 2 square plus 3 square plus 4 square and its square root. So it is going to be 4 plus 9 plus 16 square root, that is square root of 29. So let's divide the vector by this modulus. You will get 2i cap upon root 29 minus 3j cap upon root 29 plus 4 upon root 29 k cap. So from this, the coefficients of I cap, j cap and k cap will represent the DCs. So the direction cosines, what we need is the distance. So let's write the equation of plane given over here, taking this as the unit vector. So for that purpose, what you need to do, you need to divide this particular equation by the modulus root 29. So it will become 2 by root 29 x minus 3 by root 29 y plus 4 by root 29 z equals to 6 by root 29. Now this equation is in the standard form, where the coefficient of x, y and z are direction cosines and the distance is positive. So the distance of the plane from origin is going to be 6 by root 29.